Hi, welcome to Mat210, Elements of Calculus 1.7 chain rule. And this is the chain rule is an extremely important part of the derivative. And this is where you get to use all your algebra, all your kind of mathematical thinking. If you thought the other derivatives were hard, they were baby stuff compared to this. Okay, but this is the last major thing you have to remember in applying calculus to the derivatives in algebra. So I'm going to start out with a problem. The chain rule applies to situations where you have parentheses that are raised to powers, and you also have situations where you have square roots, where you have information underneath the square root that's just not a simple term. There's several terms or whatever. So let me explain. Suppose we had this function y equals. This is the bottom of page 167. Y equals 1 plus x to the third raised to the fifth power. In order to do this, we're going to use a technique called the chain rule. What the chain rule is, it's in simple words, I explained it as the derivative of the outside times the derivative of the inside of the parentheses. The outside of the parentheses times the inside. Think of this as maybe the derivative of y equals u to the fifth. How would you do a problem like that? You would take y prime, call this y prime, and the derivative of y is equal to 5u to the fourth, right? Well, we're going to do the same kind of thing here. Y prime is equal to 5 times this parentheses, 1x cubed to the fourth. But then we also have to take the derivative of what's inside. The derivative of 1 is 0, so we don't need to write that down. The derivative of x cubed would be what? 3x squared. So we write that down. So it's the derivative of the outside times the derivative of this expression here. Let's do it over here to the side. 1 plus x cubed would be 0 plus 3x squared. I should have put y. So y prime would be 3x squared. So now we're going to put this together, and our answer is going to be 15x squared 1 plus x to the third power raised to the fourth power. And that's our solution. We probably wouldn't try to expand that out or anything like that. So this is what we mean by the chain rule. The derivative of the outside times the derivative of the inside. Let me grab a pen here, see if it works. Outside, inside. That's where we're getting this 3x squared from. Okay, so we take the derivative of the outside right here, and then the derivative of the inside. All right, well, that's one of the easier ones. Yeah, not so much fun. But suppose let's look at the next page, and I'm going to write it like normally you would see this problem. Then I put function of x equals the square root of 1 plus x to the third. Okay, so first thing before we start to take the derivative of this, we want to kind of rewrite this. We're still not into doing a derivative. We're just going to write this with exponential notation. Okay, Now we're going to take the derivative, first derivative. And we want to signify that we are taking the derivative. And I'm going to scoot this up. I hope my autofocus is on. I don't know. Let me double check that. Yeah. Okay. So this is what we're looking at right here. So it's 1/2 1 plus x cubed to the negative 1/2. We're going to, subtract 1, 2 2's. Times the derivative of the inside, which is going to give me 3x squared. 3 times x and take away 1. All right, so now I want to put this in a little bit better form. Doesn't look like anything's going to cancel here. So this would be, I'm going to bring this, let's see if I can get a little bit better pen here. I'm going to bring this down to the bottom. So this is going to be 1 over 2 times 1 plus x cubed to the half power. And of course, this was on top. This is kind of in the numerator, so this would still be 3x squared. So then we could just make it a little fancier. 3x squared over 2 square root of 1 plus x to the third power. Of course, you can't cancel these because this is a whole x squared. This is a square root of x cubed. So we just have to leave it in that form. So don't be afraid to write things down. Let the pencil and the paper do the work. Don't think you have to knock your brains out doing everything here. So let's get into another problem here. Let me show you another example. This is, to me, this is a lot of fun, but, to a lot of students, this is horrific. Here's our next problem. This is separated by a plus. So this is not an ABBA problem or a Babs problem or anything like that. This is just two separate problems. Okay. Oh, I'm sorry, you can't even see it. That's that a little bit better. So on this problem right here, we have a term plus another term. All right, so y prime is equal to 3 times 1 plus x squared. We haven't done anything to it. We're just working on the outside. This became a 2. Now we're going to go to the inside. Derivative of 1 is 0, 2x. Plus, now we're going to do the second term the same way. 2 times 5 plus 4x raised to the 1 power. We put a 1 down there if we want to show we did it. A lot of times if this comes out to be 1, I still write it down. In this case, this is 0 and this is just 4. Derivative of 4x is just 4. 1 take away 1 is 0. Okay, so then I'm going to rewrite this in a little bit nicer form. 3 times 2x, 6x, and usually you can multiply those two things, and then this would be 1 plus x squared squared, plus here we want to multiply these two, 8 times 5 plus 4x. Now here we can't really do anything. We could expand it out. Did they go ahead and expand it out? I guess they did. So let's go ahead and expand it out. Y prime equals 6x times, sometimes we do, sometimes we don't. We try it. This would be a square double square. Square, multiply these together. If this was to the third power, we probably would just leave it. Multiply these together and double them. 2x squared, and then x squared squared is x to the fourth, plus 40 plus 32x, distributing. So now let's distribute this whole thing out, see what we get. 6x plus 12x cubed plus 6x to the fifth plus 40 plus 32x. Let's put them in descending order. 6x to the fifth, 12x to the third. We can combine these two. 38x. Cross that off. Plus 40. Let's see if that's what we match up with the book. They put them in the ascending order. I do have a mistake here with this 38. What happened here? Let's take a look and see where I made my mistake. 6x plus 12x plus 6x plus 40. Should have been a 26x. 12x cubed is good. And I got a minus 6x to the fifth. Maybe I copied this wrong. Yeah, this had a minus sign in it. So I think we're okay. This had a minus sign, and I copied it incorrectly from the book. So what I did here is okay. It's just, should have been more careful copying down the problem. But go ahead and just leave it and leave the solution for the one in the book. Oh, you can practice it. Now, let's try example 3 here. Y prime, or function of x, you can write it either way, is equal to 3x minus 5 to the fourth times 7 minus x to the 10th. And on this problem, I'm going to show you a little trick that's not in your book. Okay, so if you're watching this video, you're going to pick up kind of a nifty way to do these. I think it's a lot easier. Okay, this is A, this is B. Notice on this one, this wasn't A and B because they were separated by an addition sign. There was an addition sign between them. But this problem, there is none. So this is an ABBA. A, B prime plus B, A prime. Cool. So function of x, function prime x is equal to A, we're not going to do anything to it, times the derivative of B, 10 times 7 minus x to the 9th, right? Times the derivative of the inside. Now here's where it gets a little tricky because the derivative of 7 is 0. The derivative of x, you might think is 1, but there's a negative 1 here, minus 1. So this will be a negative 1. We want to be a little careful. Plus, now we're going to go with the b. b times the derivative of a. Outside, 4 times 3x minus 5 to the third. You get better at it after you do these, times the derivative of the inside, which is 3. There we go. So now let's put all this together and see what we've got. 10 times negative 1, let's write function prime x is equal to negative 10, multiplying these two. And then I got 3x minus 5 to the fourth. And then I've got 7 minus x to the 9th. Plus, I've got this 4, I've got this 3, looks like a 12. And then I'm going to put them in the same order. Since this had 3x to the fourth, I'm going to put that next. 3x minus 5 to the third. If you don't do that, that's fine. It just makes it a little bit easier. 10th. Looks pretty good. Now we have to factor it. Now you're going to use some of your algebra. We're going to pull things out of here. And we use that when we factor, we got something like 3x squared plus 6x. We're used to pulling out a 3, and an x, and we got x minus plus 2, something simple. But here we got something a lot more complicated. So Let's look at the 10 and the 2, and I'm going to show you a little trick I use. 10 and 2 is, I got 12, I mean, it's a 2. And I don't know if the book pulled out the -2 or it didn't pull out the -2. Sometimes they do, sometimes they don't. Okay, looks like they didn't bother pulling out the -2. They just left it as 2. Okay, but before I write that down, what I'm going to do is I'm going to pull out a 2, but I'm going to put it under each one of these. You may have never seen factoring done this way. I'm going to pull out a 2 out of both of these. And I'm going to write it down under each term. The terms are separated right here by this big plus sign. Okay? Now I see a 3x minus 5 to the fourth and a 3x minus 5 to the third. So I'm going to take out the smallest one to the third, to the third. Now I see a 7 minus x to the ninth and a 7 minus x to the 10th. So I'm going to pull out the smallest one. A friend of mine showed me this little trick that was doing calculus. And I thought, man, that's pretty cool. So this is my common factor. F prime x is equal to 2 times 3x minus 5 to the third times 7 minus x to the ninth times, and now I wanted to figure out if I took these out of here, I took out the 2 and I took out the 3x minus 5 to the fourth, to the third, and then to the ninth, what would be left? And by doing it this way, I can see, okay, 2 goes into 10, -5, and this would be 3x minus 5 to the 1. Let's make this a bracket. That might be better. Should have made it bigger too. Let's bring it over here. And then I see I got, these did cancel, huh? Now I got a 2 into the 12, which is plus 6. And I have these canceled out. And now I have 7 minus x to the 1 power. And these usually end up with powers of 1. Now I'm going to distribute that out. I'm not going to multiply this out yet. And let's see what we got. We got negative 15x plus 25 plus 42. Drawing is terrible here. Minus 6x. Let's hope I got that right because I can't hardly read my own writing. Let's see if that's what they had. Plus 25 plus 42. Yeah. And now what I'm going to do is kind of simplify that out. And this should be my answer. 3x minus 5 to the third, 7 minus x to the ninth. And now I'm going to just combine my terms. Here's a negative 21x. And here's a, 67? And there's my answer. See, I want my answer in factored form. They arranged this and put the 67 first, but that's not necessary as long as you have these 3 terms, or 4 terms, I should say. 4 quantities. I don't know what you're going to call them. Okay. Isn't that fun? Okay. Do we even want to try this last one? This last one's pretty horrible. Let's see if we can do it. Need a lot of paper for this one. Function of x. Did this help you? Before we jump in, did this help you writing our common factor? This is the common factor we factored out under each one. And that became our common factor. But by putting it under each quantity here and here, we can kind of see, makes it a little bit easier to visualize. I use it all the time, but especially on these kind of problems where Pretty horrible problem, huh? Okay, so I'm going to rewrite this as x plus 3 to the 1/4 power over x minus 2 to the 1/4 power. So I'm going to rewrite them in this form right here. Okay, and I'm going to have to do an ABBA on this. This is A, this is B, and we want to do a BABS, not an ABBA, a BABS, huh? B, A prime minus A, B prime, all over B squared. So let's see what we can do. Function prime x. Give yourself plenty of room. You're needed. Okay, B. X minus 2 to the 1/4. Sorry, the voice. Times the derivative of A. 1/4 x plus 3 to the 1/4 minus 1 would be a negative 3/4 times the derivative of the inside, which is 0 and 1. So I'm going to write the 1 down. You don't have to, but it just reminds me that I took the inside. Okay, minus A times the derivative of B. Okay, the derivative of B is going to be 1/4 x minus 2 to the negative 3/4 times the derivative of the inside, which again is lucky, it's just a 1, divided by x minus 2 to the 1/4 squared. Just going to write this down. I'm not going to put it underneath because x minus 2 to the 1/4 squared. That'll be 2/4 or a half. Okay, so I'm not going to write this part under here yet because I want to see what I can factor out of here. Let's distribute this out. We actually don't need to distribute too much because the ones we don't need. So what do we see here? Both terms have a 4th. Okay, we can take that out. And we can put that under each one. 1/4, 1/4. Okay, I'm going to factor out the 4th. They also, both of them have an x minus 2 to a 4th and to a negative 3/4, which is to a 4th, yeah, and a negative 3/4. Negative 3/4 would be the smaller. X minus 2 to the negative 3/4. X minus 2 to the negative 3/4. And same thing happens here. This would be the smaller. X plus 3 to the negative 3/4. X plus 3 to the negative 3/4. So that's what I'm factoring out. Let me write this down. F prime x equals 1/4 x minus 2 to the negative 3/4. I'm going to kind of write it like this so you can kind of see. X plus 3 to the negative 3/4. Pretty horrible problem, huh? This is about as hard as they get. Okay, now what happened here? Make this big so we got plenty of room. Well, here they canceled out and here they canceled out. So we just kind of worrying about this part. Let's bring this up to the top. X minus 2 to the positive 3/4. And 3/4, and it's kind of sloppy here, 3/4 and 1/4 become 1. So this is just x minus 2 to the 1 power. Plus, minus, okay, what cancels here? Cancels, 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 cancels. And up here, same thing. I bring this up to the positive 3/4, 3/4, 1/4, x plus 3 to the 1. Now remember, it's still over an x minus 1, 2 to the 1/2 power. Kind of don't have enough room there. It's kind of coming off the page. Okay, so let's simplify this. Let's just write it all out again, because it's kind of sloppy here. Now let's see what we got here. We got x minus 2 minus x minus 3. So these cancel out. They add up to 0, and this is a negative 5. Now I want to divide this whole thing by the x minus 2 to the 1/2. So let's see what I end up with. One half, let's change 1/2 to 2/4. Let's leave that as 2/4. So when I bring this down, this is going to become x minus 2 to the 3/4. And when I bring this down, this will be x plus 3 to the 3/4. And then the negative 5 is going to stay. So I'm going to bring these down to the bottom. This comes down over here. This comes down over here. I'm going to bring those down. So I have pretty messy. That's why you have to be kind of careful. I have a negative 5 on the top. Let's change that to just a 5. On the bottom, I have 2/4, and 3/4 is going to give me 5/4. And I'm going to leave it like that. And then I'm going to leave this as x plus 3 to the 3/4. And is that what they came up with? Certainly is. Maybe not the same order, but the same thing. So you can see it's really kind of a complicated mess. You might want to stop the video, replay it, or try it yourself. But that's why I try to write this underneath there. It makes it easier for me to cancel. I don't want to write this down right away. I want to work on that denominator. Remember, this was x minus 2 to the 1/4 times 2. So that gave me x minus 2 to the 2/4. So you have to be pretty good at fractions. You got to be pretty good at algebra. You got to be pretty good at everything to do these problems. Let me try another one that isn't quite as difficult, but it's still a hard problem. Okay. How much time we got here? Let me try a couple off your homework. Okay. This is on page 174. Let's see which problem I did. Let's try a simple run. Let's try 17. This is on 173, number 17. If you have a book, if not, you can just watch. Now, one thing we could do with this problem is we could expand it, but you can see that expansion is going to be maybe cubed, not so bad, but then you get into the fourth, it's going to be a big expansion, pretty hard to do. The next thing I noticed is was there a minus between these two problems? Let's double check this, see if I wrote it down correctly. Yes. So this is indicating that this is not a BABS or an ABBA or anything like that. It's just two separate problems, two terms that we're working with. So function prime x is equal to. So we're just going to do our simple chain rule 3 times 1 plus x to the third power to the raised to the second power times the derivative of the inside. What's the derivative of x cubed? 3x squared minus, here I'm going to do the same thing. This is going to be 4 times 2 plus 8x to the 8th raised to the third power times the derivative of the inside. 2 is 0. This is going to be 8x to the 7th. Okay, I'm going to try to simplify a little bit. I'm going to multiply this together. Let's see, this would be 3x squared times this would be 9x squared times 1 plus x cubed. And we can't distribute inside. Don't think that's, I don't know, 1 plus x to the 6 or something. No, squared. Minus 32 x to the 7th, 2 plus x to the 8th. Okay, we notice that was inside x to the 8th cubed. Sorry, that's an 8. Okay, we notice that these two parentheses are not the same. So the only thing I factor out is the number that goes into 9 and 32. What would that be? I don't think there is any number that would go into 9 and 32, is there? Let's see. So I don't see much else you could do to this. The only other thing you could do is maybe factor out an x squared out of both of these. What would that do? That would give me 9 times. I want to write my x squared down. And then I got 9 times 1, excuse me, x squared. I don't know if I would even take that out, to be honest with you. I think that's just going to make it more complicated. You could take it out and then put x squared times the whole thing, you know, but 9 times 1 plus x cubed squared. I don't know. I don't know if I would. You could go ahead and distribute that out. I probably wouldn't. And then this would be x to the 5th, 2 plus 8, x to the 8th cubed. I don't know if it really pays to take out that x squared in this case. You know, you might have just left it right there. All right, let's try another one here. Let's try one with a little alpha here. What problem is this? Don't forget, we're going to have a live Zoom. If you're stuck, you can turn on the live Zoom and watch it and you know, kind of help you out a little bit. I'm trying to find this problem. I can't even find it. The reason I wanted to do this one is because it's very similar to the last one we did. I'm kind of running out of time, so let's see what we can do with it, though. I can't find which problem it is in the book offhand. Okay, you see the difference on this problem? This had a minus sign between it. This is a times. So this is definitely an ABBA, A, B. So we're going to have A, B prime plus B, A prime. Function of x, function prime x is equal to the first derivative of x is A times the derivative of b. What's the derivative of b? 10, 7 minus x to the 9 times the derivative of 1x, which is negative 1. Be careful about that. Plus b times the derivative of a, which is 4 times 3x minus 5 to the third power times the derivative of the inside, which is 3. What most students goof up on is they do a good job on this, and then they forget to take the derivative of the inside, and it throws them off. All right, let's put some of this junk together, see what we have. We have a negative 10. We've got a 3x minus 5 to the fourth. We've got a 7x, 7 minus x to the 9. On this side, what do we have? We have a plus 12, 3x minus 5 to the third, and a 7 minus x to the 10th. We're going to factor out the smallest, 10 and 12, we get, which they got a negative 2. And what you could do over here is right away write down, here's your negative 2. This is what you're factoring out. You have 3x minus 5 to the third, 3x minus 5 to the fourth, 3x minus 5 to the third, smallest. 3x minus 5 to the third, smallest. I forgot to write my negative 2 down there. And you could write it here right away if you want. And then 7 minus x to the 9th, 7 minus x to the 9th, the smallest. 7 minus x to the 9th. So we've taken all this out of here. Now we want to see what's left. Bing, bing, a 5. Bing, bing, a 3x minus, put a bracket, minus 5 to the 1. I'm going to write a 1. Here we got a minus 6, cancels, and a 7 minus x to the 1. So let's distribute that out. You can see there's a lot of writing on these problems. Easy to make a little mistake. And here we got, you might just jot it down here, 15x minus 25 minus 42 plus 6x. Trying to be careful about signs, kind of doing it in a hurry. Hopefully I didn't mess up. 21x minus, looks like 67. And that is correct. So I took out a negative 2. You could also have not taken out a negative 2, maybe you took out a positive 2. If you took out the positive 2, which is what they did in the book, let me show you what that does to this problem. Gives you the same problem. But if you didn't take out the negative 2 here and you left it as just taking out a 2, then what happened is these two are switched. It'd be 67 minus 21x. That's all. This will become a positive and this will become a negative. So, you can do it either way. You can take out that negative 2. That's why, sometimes when you're grading on multiple choice tests and somebody marks you wrong for this and marks you correct for that, they're both the same thing. It's just a different way of factoring. So I hope you enjoyed this video. These are going to be tough. You might have some questions you might want to ask. On Wednesday, we have a jam session. And you might want to come in and give me a problem and we can try to solve it and see where you made your mistake. You really have to do these problems. And then you also have another quiz that's kind of a review of all the factoring you've had so far. And all the derivatives you've had so far. And this would be kind of like the final part on understanding derivatives, We have a couple other type of derivative called implicit derivative. We're going to work with higher order derivatives, but these are the main derivatives that you're working with. So good luck to you.